Hello guys, welcome back. Today we're going to be talking about how to convert from rectangular form to polar form for representing a point. So as you can see, I got my x-axis and I got my y-axis. And I have this point right over here. Now this point can be represented by two numbers. It's represented by the x-coordinate it's on and the y-coordinate. So I can say this point has the coordinates x comma y. However, another way to represent the point is through something called polar form. You would represent the point in polar form with essentially the radius, and you call this r. So imagine if you found out the length from the origin all the way up to that point. You would call this r. That's basically the length right over here, and it would also form an angle with the x-axis, which we can call theta. So another way to represent the same point is this length right over here that we have, comma, the angle that it forms with the x-axis. And so this is just the basis of rectangular form to polar form. You're trying to find this length right over here, which you can do using a Pythagorean theorem, and you can find the y value through trig. Let's get to it. So imagine if I have the point, and let's say I'm only going to focus on the first quadrant here, and I'll make it simple. So let's say this is the point 3, 4. So that means that this right over here is a length of 3, right? And this height right over here is a length of 4. So notice how if we try to find a length from the origin to this point, you're just going to make a 3, 4, 5 right triangle. Therefore, our r value, the distance from the origin to that point, is 5. Now what about the angle? Well, to find the angle, well, what is this side? This side's the opposite side. What's this side? This side's the adjacent side. I know tangent of this angle is equal to this opposite side, 4 over the adjacent side, 3. If I take inverse tangent of both sides, I should get my angle. So let me just put this in degree mode so that everything works out. I get approximately 53.1 degrees, or if you're calculating it in radians, you get whatever value that is. But that is essentially, that's essentially how you convert it from rectangular to polar form, right? So to find out the radius, to generalize this, to find out what the radius, you take your x squared plus y squared, and that's going to be equal to your radius squared. So to find radius, you just square root both sides, and you get that the radius is equal to the square root of x squared plus y squared. And to find this angle right over here, well, you remember, we took the inverse tangent of this. So it's going to be the inverse tangent of the opposite side, right, which represents the y value, over the adjacent side, which represents the x value. And that is all you need to know for this. Now I got a question for y'all. What if you're given the r value and you're given the angle, and you want to convert back into plain old rectangular form, x comma y? So this is converting from polar coordinates to rectangular coordinates. How do you undo this process, right? And so it's pretty simple. Let's use the same example that we did before, where our radius was 5. I just like calling it radius because it's kind of like the radius of like a circle, if you like draw it like that. And let's say that the angle is 53.1 degrees. All right, and we want to find out, well, the x and the y coordinate. So we're going to draw out our coordinate plane. We know that whatever this point is, it's at an angle of 53.1 degrees, which we know is in the first quadrant. And we know that this radius is 5. So given this angle and given this radius, how do we calculate for the x and the y coordinates? Well, what's x? X is that adjacent side. 5 is our hypotenuse. Adjacent over hypotenuse, that's cosine. Cosine of our angle, right, which is 53.1, is going to be equal to x over 5. And likewise, to find the coordinate, I can say that sine of the angle, 53.1, that's going to be equal to opposite, which is y, over the hypotenuse, which is 5. And so, you can just easily multiply both sides by 5 to get the result. So if I search up 5 cosine of 53.1 degrees, well, what do I know? I get a value that's 3, so x is equal to 3, and I do 5 times sine of 53.1 degrees, and what do I know? We get 4. And those are the original coordinates that we started out with. So to generalize this, I can say that x value is equal to r cosine of the angle, right? That radius multiplied by cosine of that angle. And to find the y value, I do r sine theta. And there we go.